Welcome to Chem at Reedley College. My name is Dr. K, Kirk Kawagoe, and I've been teaching here for a few years and in the district for like, 23 years or something like that. I used to be at City College. What I want to do today is sort of introduce you to some of the safety rules for the lab, and there'll be a quiz. You'll have this document, electronic form, and then what you'll do is you'll go ahead and read through this. And then at the back, there's a little place for your signature. You don't need to worry about signing it. I just need you to type it and upload the form back to Canvas. There'll be an assignment for doing that. And that's how we'll track your acceptance of everything that's on the safety contract. So the first thing to talk about is attire, what we're going to be wearing in lab. For this semester, we'll also include safety masks. So you have to wear something to cover your mouth in case you're sick or things like that. And we'll also have checks at the door, and I'll have another video on that. As you come in, we'll have a questionnaire every day that you have to fill out. Probably that'll be electronic. We don't really know yet. We're still kind of working out the details at the time of this recording. You'll need a lab coat. Mine is tie-dyed, but yours does not have to be tie-dyed and fancy like this. You could have it be just a standard white lab coat. Needs to go down to about mid-thigh or knee. Okay, so it's to protect you from splashes. And the other thing that you'll need to have is goggles. Okay, so if you don't have a mask, if you don't have goggles, and if you don't have a lab coat, at the beginning of the lab, you'll have to go back and get them. Okay, before you're allowed entry into the lab. So just know that ahead of time, so to make sure that when you come to lab, you're ready and you can be admitted and be allowed to do your work, okay? So the next thing to do is talk about your conduct in the lab. And to start with, there's no eating or drinking or smoking. I don't know why I put that in there. Chewing tobacco, chewing, anything like that is not allowed in the lab because it's a route for contamination of chemicals if you accidentally ingest them. The other thing is that you should avoid contaminating yourselves, which means like as you leave the lab, you should always wash your hands as you get ready to leave, so you don't have anything on your hands that you can actually get. You should try to avoid touching your face, just like any lab situation, biological or chemical. You can get things on your hands, so you try to avoid touching your face with your hands, even though it might be a little uncomfortable, like your goggles will be really annoying and you want to do things with them. It's okay to adjust them, but try not to be like scratching your face, because you can get like pretty serious chemicals around your eyes and stuff, and they're very sensitive and can cause damage. The other thing that I want to do is sort of take you a tour around the room. So right now we're in Physical Science, PHY 82, right? And this is the main entrance to the lab, okay? So you'll notice we have a fire extinguisher. Now that fire extinguisher, I really don't want you to try to use it unless you've been trained. So that's kind of the caveat. You know, that's for putting out fires, but unless you've been trained to use a fire extinguisher properly, a lot of people end up actually making the fire worse by using it. So in that sense, if there's a fire, you need to evacuate through the two doors. Now, if the fire is by one of the doors, right, you're gonna have to go through the other door, right? Now, and on top of that, if you're not trained in the use of the fire extinguisher, don't try to use it, okay? We also have a fire blanket. It's mounted on this wall. So it's to the right of the room as you come into the room. We also have gloves, by the way, and we'll have masks as well. But you need to bring your own, but we'll have like, just in case you forget some, I think we're gonna have some extras. So the fire blanket is for a number of purposes. If you have a fire on your desk and it's small, or your work area and it's small, if you actually throw the fire blanket on top of it, it'll put the fire out. It's actually meant for being used on people. So if you catch yourself on fire, the thing that you need to do is do the stop, drop, and roll thing, and then get the fire blanket on top of you to make sure that you smother out the flames. Now, of course, you're on fire, right? You're not grabbing the fire blanket. You're gonna stop, drop, and roll, and then other people should pull the fire blanket out so they can put it on top of you, okay? Now, having said that, there's also a eye wash. Now, this is our eye wash station right here. Okay, and the way that it works is there's this lever on the side, and when you push this down, water will come spewing out like that. Now I'm going to turn it off right away because one of the things about the way this has been set up, and it won't be this way in the new labs, is there's not really a drain for the water, so it just comes out on the floor. It can get really slippery, okay? And then ignore the electrical outlet that's over here, okay? Anyways, yeah, it's not well designed. But it'll work. If you get something in your eyes, don't worry about your contact lenses. Don't worry about anything else other than getting your face over the water and washing it out of your eyes. It needs to go for about 10 to 15 minutes. And that's, I don't know if you've ever tried to hold your eyes open underwater like in the swimming pool for a long time. It's not easy, okay? So a bit of a struggle. But again, be careful when you turn this thing on because the way it's set up, the water comes out of the bottom and it gets really slippery. We also have a shower, so in case there's a chemical that somebody drops a bottle, this is the most common way this happens. Somebody drops a bottle, it shatters and liquid goes all over, right? Well, at times, the best thing to do is just to wash it off. And so I won't demonstrate this because it's quite a mess. You grab this and you pull it. That activates the shower on that lever. You can see it right there. Okay. And then that'll bring water out of that. A lot of water out of that. Okay. So again, there's nowhere for it to drain, so the floor becomes quite slippery when that happens. Now, I forgot to mention, as I was walking past, we also have a first aid kit that you can use, right? This is the first aid kit. It'll have Band-Aids and stuff in it, so like if you get a little cut or something, just let me know and we can put a Band-Aid on it. If you need one when you come into class, feel free to ask me for a Band-Aid and I'll get you one. There's also a first aid kit in this room by the other door. You can see it in blue. Sorry, this room's a little bit of a mess because we've been storing all kinds of stuff in here this summer because of COVID, but anyways. There's another first aid kit. Okay, and then at each door, or actually at the main door, we have hand sanitizer as well. So when you come in, you can use some hand sanitizer. As you leave, you should probably use some hand sanitizer. Wash your hands and use hand sanitizer. So a couple other things about when we do labs. We need to dispose of the chemicals that we use correctly. And for that, we have these waste bottles that are down underneath the hood. Now, when you need to do an experiment, or when you're doing an experiment and you've generated waste, typically we'll collect that in a beaker. And like oftentimes you'll collect it at a beaker at your desk, and then you'll come to the hood, right? So, you know, you talk about the hood, right? This is the hood right here. It's actually called a fume hood, and it's designed to take out chemical fumes that are generated during an experiment, right? There'll usually be a beaker in here during the lab that you put your waste in, and then the rest of the process involves our lab technician, Austin, and he will dispose of the waste in the bottles down below. Now, if the waste beaker gets full, stop adding stuff to it. I don't know how many times students will look at that beaker and it's almost filled to the top and they'll think, I get a little bit more in there. You know what happens, right? It goes all over the surface. All right, so when you have waste, right, you'll have a beaker at your desk usually, or your work area. You'll handle the waste with that beaker, and then you'll take it to the hood and get rid of it in the hood. All right, and then Austin will handle it the rest of the way. So just a couple of other things about conduct in the lab. One is we have chemicals set out for a particular experiment. Like if you saw a video and you said, oh, hey, I could use this to do this other really cool experiment, this is not the time to do it, right? Only stick with what you've been told to do with the chemicals. So no side experiments. I don't know why, you'd want to do that. That's why I became a chemist, I guess. So I could do all these side experiments. But just so you know, Yeah, that's not allowed. And if you want it, like you saw something online, you say, oh, that's really cool, and you want to do it, just let me know. And oftentimes we can just arrange to do that as a demo. But we like set it up for the next day so we don't use the chemicals that are intended for another purpose, okay? And lastly, and this is important, as you leave each day, we have cleaner for the counters, and we're going to have sanitizer for the counters and the equipment that you touch. We need to make sure that we clean the counters off really well, and then also clean any of the equipment that we touch, just in case, to avoid like the spread of, one, chemicals, really that's why we do it, but also if somebody is positive for COVID or something and doesn't know, we can clean that up, and then more cleaning will get done. You're not the last line of defense on the cleaning, but it will just make things better if more people pay attention to the details of cleaning their area when they work. So I've got these two beakers here, right? You see those? Let me do something really quick. So this is a temperature gun, 25 degrees Celsius. This one, 212 degrees Celsius, okay? They look the same, right? 212 degrees Celsius, that will burn your skin off, okay? It's really hot. They look exactly the same. So one of the warnings about labs is, be careful about where you set your hot glassware. If you leave it on a counter like this and somebody says, oh, I just stuck my beaker there, I'm gonna pick it up, and they pick up your beaker that you just heated up, that'd be a problem, okay? So be careful with glassware. Two things, hot glassware and cold glassware look exactly the same, okay? Unless it's red hot, then they look different for sure. The other one is, if the glassware that you have, see now I know which one's hot because I did it, right? Has cracks in it. Now this doesn't have any cracks, but what you should do is you should inspect along the bottom and the edges. This is where people most often ding things, and look for little cracks. There's also along the edges at the top, you'll see cracks. Now a chip here sometimes okay. If it's rounded, that is, it isn't sharp, it means that we saw it earlier and then we heated it to relieve like the crack that's there. But cracked glassware, when you heat it, most often cracks more. And then if you have it full of liquid, that liquid goes everywhere. If you have it full of a flammable liquid and you're heating it with the flame, then that flammable liquid goes everywhere on fire. Okay, so thing to remember, check your glassware to make sure it doesn't have cracks. And if you're heating glassware, and we do this often, we take equipment and we heat it up to get water, moisture, and impurities off the glassware. Just make sure that you put it in a designated place. We often have wire gauze, and I'll show you what that looks like. All right, and if you have something that's really hot, you can take it and set it on there, and that can be an indication to people that that's the hot one, this one's not. People should know not to touch that because somebody just heated it up so that it would cause like a burn if somebody were to grab it. And also, if you don't want people to steal your glassware, it doesn't hurt to just stick it on there. Okay, so there you go. There's oftentimes we have to take a piece of glass tubing or thermometer and stick it through like a rubber stopper. When we do that, I will give you specific instructions on to do that, how to do that if we do it. But typically we use glycerin, that same stuff they put in the fancy soaps to like make your skin soft and protect you from losing moisture. We also use that for lubricating stoppers so that we can put a glass tube through it, okay? When you do that, what's best to do is not to grab the glass up here and push it through a stopper down here. It's to work down here and push the stopper through close, or the rod through close to the stopper, so that if it breaks, you're not shoving your hand into it. It's pretty common, a pretty common accident in labs, is for new people especially. They'll take a stopper on this end with a hole in it and a glass rod over here, and they try to shove it like this, and when it snaps, they just jam it into their hand on either side. So try to avoid doing anything like that. But like I said, if we do that this semester, I will warn you like right beforehand what needs to be done. Okay, so I'm about to do something that's ill-advised. So I have a Bunsen burner and I'm going to heat a liquid. This is actually the next section, and I just wanted you to see why you avoid pointing. This is a test tube. All that is water, so it's not really dangerous. I'm going to show you what happens when you're not paying attention. You're heating water, it's getting hot, and you're not paying attention. It happens pretty quickly, by the way. I don't know if you can see it's starting to boil at the bottom. All right, it should happen here any second now. Oh, there it goes. Almost happened. There it goes. So you see all that squirt out like that? It's called bumping, okay? It's what happens is you're heating the glass so fast, it just creates one giant bubble of water vapor and it shoots everything out of the top of the test tube. So when you do something like this, typically we'll add something to it to help it to boil more smoothly. But you need to make sure anytime you're doing it, especially when you're new at this, or if you're tend to be inattentive really, that you don't point it towards somebody, because most of the time we're not heating water like this, we're heating something else, right? So when you're heating a liquid in a test tube, and we try to avoid doing that kind of heating in general chemistry. We usually do it in a beaker and it's not as big a problem, but it can happen. But we try to avoid some of that in Chem 1A or Chem 1B, just because it can cause the liquid that you're heating to shoot out and spray onto somebody across from you. If I had filled the test tube up, the whole contents of the test tube would shot out. All right? So that's one more thing to be careful of as you're heating substances in a test tube. There's the possibility that it'll bump and it'll shoot all the liquid out of the test tube. The other really important thing to do, which would have been fun to do, but like I said, it's dangerous. Don't use flammable liquids when you're using a fire, okay? There are times in organic chemistry where flames are used, but it's under very specific and controlled instances. We will have flammable liquids in the room, so if you're heating with an open flame, that's what we refer to as an open flame, make sure you don't have any of the flammable liquids around you. Okay, so you're going to say to me, how do I know it's a flammable liquid? That. The cap has a different color. Right, water, it's blue in these labs. This is actually acetone, and some of them are green for like methanol. I don't think we have any of those in here, but this is red and this is usually acetone. Sometimes it's ethanol, but typically it's acetone. You need to be careful when you see this lid that you take it off of the work area, and then you can stick it over here by the window, or more I guess what would be better, I was going to say more better, but you know that's not right. Let's stick that in there in the hood, okay? So make sure when you're heating liquids in a test tube or heating liquids in general, if you're using an open flame, don't use flammable liquids. If you're heating it in a test tube, just make sure you're not pointing it towards somebody in case it bumps, okay? But the most important thing is just be attentive to what you're doing. Like you'll notice, like it took quite a while for that water to bump out of there. You really have to not be paying attention. So pay attention to what you're doing, and these things don't usually happen. Okay, so a couple of things about handling chemicals. And I'm not gonna, there's some things that I'm not reading off this list, but just the things that I think that need to be emphasized. The quiz will include questions potentially from all the items on the safety sheet, including the things like I say in the video. Let's say you needed to get some sodium hydroxide, right? This is not on the sheet. Don't pour it like this, okay? What you want to do is you want to put it into a beaker or something that's easy to pour into before you pour it into the container that you're going to use. So oftentimes you'll have a beaker available, right? And you'll check it for cracks and that kind of stuff. And you'll pour the sodium hydroxide, for example, into this beaker. Now, in experiments that we do, you typically need 100 to 150 milliliters, right? And you can look on the side. These will give you guidelines. You start at the low end. This is 20, 40, so 150. You know, that actually would be like just past the 140 mark, right? Oftentimes I'll tell students not to get everything at one time. And then when you store it at your desk, you'll use what's called a watch glass, and you'll learn some of these things as the semester progresses. You put a watch glass on top so that the liquid doesn't evaporate out, okay? Now, when we pour, and this is like a house rule, you know, like Monopoly has house rules, right? This is a house rule. You'll take, right, you open this up, set this aside somewhere clean. I typically set it up or to the side on top of another piece of glassware or something like that. But sometimes I just hold it, okay? And then you pour like this. But you'll notice where my hand is. It's on the label, okay? So I put my hand on the label. I double check to make sure it's the thing I wanted. And then I open it up. And then I pour it into whatever container that I'm going to be taking it in, okay? Now, why do we do that? If everybody does that, let's say the liquid dribbles on the way out, you know, like a milk or anything like that, right? It dribbles as you pour it. Well, it'll be on this side. And if everybody grabs it from this side, then you'll never get it on your hand or your gloved hand because it'll always be on this side. This side will be easy to clean. And also, this side has the information on it that you want to keep preserved for other people to see, and so it won't be getting on top of this and erasing it, okay? So that's one of the things that I like to keep track of, a house rule. When you pick up a bottle and you want to pour from it, you look at it, you double check it's what you want, you open it up, and then you always pour away from the label, and that'll avoid some like contamination issues. Now, let's say I was wrong, it wasn't 150 mils that you needed, you only needed 15, right? You have 10 times too much. Don't put it back. If you put it back, right, into this blue lidded bottle, you might suddenly find that you poured it in the hydrochloric acid bottle by accident and ruined the experiment for everyone, okay? In which case you have to wait around till it gets remade to do it. Now, so what do you do with the extra if you only needed 15 mils? You tell people that you got too much, and then you can give it to them, okay? There are some social distancing rules, okay? So we might have to make it so you take that beaker with too much and stick it next to this bottle and people can pour from that. But typically it's not a big deal. We usually make a lot of extra and then we just dump it, we get rid of it. These are made from very concentrated materials typically, and so what's actually in this bottle is not that expensive to get rid of typically, okay? So it's easy for us just to get rid of it and not worry about cross-contamination issues and things like that, okay? So get too much by accident, don't put it back in the bottle. We'll figure out a way to redistribute it, or worst case scenario, we'll just dump it. But if a bunch of you do that, then we'll run out of this material and it'll have to get remade. And again, like I said, that's a mistake not on us or the lab tech. It's a really mistake on whoever did that, and we'll all end up sitting around waiting for it to be remade so that we can continue with the experiment. Okay, next. Let's say you spill some acid, okay? We typically have a way to clean up acids, usually sodium bicarbonate baking soda, and we pour that on and we neutralize it. If you're never sure about like how you clean something up, just approach me and say, I spilled X, Y, and Z. Let the people know around you that you spilled it so they don't walk through it, and then I'll show you how to clean it up. It's usually not hard. Most of the time, the stuff that we deal with is safe enough that you can wipe it up with a paper towel, neutralize it, and then dump it in the trash, okay? So the last thing to talk about spills and mishaps like that is if you get it on your skin, you need to wash it off. We do have gloves, we have plenty of gloves, and those are free for you to use. I recommend that you change them at least once an experiment, if not more often. you'll find that these gloves, for some people, like for me, within a matter of 20 or 30 minutes, they start tearing. For some people, they'll just stay on their hands the whole lab period and they don't have a problem. So I don't know what the difference, but it's like a chemical thing with your skin, I think. That's like hearsay. I don't really know that it's true, right? You could fact check me, but I don't know. So anyways, yeah. So other thing, if you get something more severe like a cut or a burn, I need to report that to the nurse and they'll double check like you're okay, right? And if you need to be attended to because of it, they'll take care of that through the college, okay? So the last two statements on the safety contract deal with special medical conditions and pregnancy. So I would normally read that out, and I may like read it to you on the screen, but please read those. It has to do with students with medical conditions who might lose consciousness. You need to let us know if you have one of those. That's a safety issue. I've had students with insulin pumps. I had one student who had diabetes and told me because the previous semester somebody had epilepsy and didn't tell their instructor, and they just walked off one day during lab and had a horrible seizure in the bathroom. And nobody knew until another student went into the bathroom and saw them there. So, you know, please tell me about those things. And if you think like something's coming on, just because you know, a lot of times you kind of know, you have a sense, right? It's your body and you're familiar with it. Just let me know so that we can do this safely, okay, as safe as we can anyways, and get the right people coordinated to help you out. And the other statement has to do with pregnancy, and it has to do with really, for many chemicals, we don't really know like the long-lasting implications of the chemical. And so if you are worried and you are pregnant or become pregnant during the time period that you're taking this class, talk to your doctor, and your physician should be able to recommend what you do based on a list of chemicals that we can give you that are used in our general and organic chemistry labs. So having said that, at that point you will type in your name, and on the signature you will also type in your name and put a date, and your student ID goes here. On the reverse side, it says section number, so you'll type your section number in there, although I'll know it because what you'll do is you'll upload this to Canvas. I don't want you to print it out. I just literally want you to type the information in. I'll make it so that you can do that. And then you save it, and then you re-upload that file to Canvas, and then that will have your student ID and identifying information on it, so I know that you did it. I'll double check that you filled it out. The other part of this is there will be a quiz covering the contents of this, and so you'll have a digital copy of the document that you can go through. It's open book, so it's not hard, but I'm going to ask you questions. There'll be a question bank of probably 20 questions. You know, you have to get a certain number of them right, something like that. The goal for that is, though, not to have you fail it, is to have you pass it. And so you can take it many times. It'll randomize questions and stuff like that. You take it many times until you get a passing score. If it takes 10 times, then it takes 10 times. If you get it the first time, that's great, right? So, but the idea is to get you exposed to the information so that you are familiar with the protocols and things you need to do the lab safe.